In this video, we're going to talk about how to find domain of a function. So let's take a look at our first example. We want to find the domain of the function f of x is equal to x squared minus x plus 4. So if you notice, this is a polynomial, which means this function satisfies everywhere on the real line. So therefore, the domain of this function, which we're going to call it dom of f, it's going to be negative infinity to positive infinity. Because it's a polynomial, it satisfies everywhere on the real line. So that's the domain of this function. Not really much work to do, it's just understanding that this is a parabola, it satisfies everywhere on the real line. Let's take a look at another example. So for this one, we want to find the domain of k of x, which is a square root of x minus 3. Now you have to keep in mind that the square root function has to be always greater than or equal to 0. So we want the expression under the radical to be always greater than or equal to 0. So we take that, x minus 3, and set it as greater than or equal to 0. And then we solve for x, so we add 3 to both sides. And that would give us x has to be greater than or equal to 3. So that's the domain of this function. As long as x is greater than or equal to 3, this function is fine. So in interval notation, we will say the domain of k, it's going to be starting at 3, so bracket 3 all the way to infinity. So that would be the domain of k of x. Okay, let's try another one. Let's try this one. Now this is another function that we're looking for domain. And again, it has a square root in it. But now the difference is the square root is on the denominator. So that means we have to make sure two things. It's not equal to 0 and it's greater than 0. So to put the two ideas together, we take what's inside the radical, which is x minus 1. We set it strictly greater than 0. So note the difference between the previous problem and this one. Previous one, we want it to be greater than or equal to 0 because the radical happens to be on top of the fraction, if you were to think of it that way. But this one, since it's in the bottom, we want it to be strictly greater than 0. And then we go ahead and solve for x. So we subtract, add 1 on both sides to get rid of that negative 1. Then we arrive at x is greater than 1. Now keep in mind, x cannot be equal to 1 because then you have 0 on the denominator, and that's undefined. So that will be the domain of this function. So we would write domain of g. It's going to be starting at 1, but not including 1. So open parentheses, 1 to infinity. So that will satisfy this function. Okay, let's try another one. Here's another example. So let's think about it. This function, we have a radical and we have something in the denominator. So that means we need to take care of two things. We have to make sure the top is greater than or equal to 0 because of the radical. And we also need to make sure that the bottom is not 0. Because if it equals to 0, then we have undefined statement. So we have to consider both of these cases for the domain of f of x. So let's consider the top first. When is x greater than 0? Well, if you just take what's inside the radical, which is x, so we want that to be greater than or equal to 0. So now it's okay to be 0 because it's on top. So that's one restriction. Let's draw that on the real line. So everything that's greater than 0 or equal to 0 will satisfy the top. So that's for the top. Now for the bottom, we don't want it to be 0. So when will the bottom be 0? Well, if we take x minus 12, set it equal to 0, and we can find the x value when this expression is equal to 0. So by adding 12, we get when x is equal to 12, the denominator will be 0. So that means from the domain of the top piece, although we're considering everything greater than 0 is fine, but 12 happens to be greater than 0. So that means when we hit 12, we kind of have to open that circle because we cannot have 12 in our domain. So we're going to put an open circle at 12. So this is how it's going to look like. So we put an open circle at 12, and then everything else is fine. So that's the domain of the entire piece, the top and bottom together. Now, if I were to express this using interval notation, we would say domain of F is going to be 0 is included up to 12. We cannot include 12, union. And then we can again start from 12, but not including 12 to infinity. So that would be the domain of this piece by considering the top and the bottom. All right, so I hope you found this helpful.